All right, so implicit differentiation today. Before we get started, we've got a little warm-up here. Quick, simple, easy. We've got sine of 7 pi fourths here. Okay, and again, I know that sine of pi fourths is 1 over root 2. So that's one of the ways you can write this is 1 over root 2. But because it's 7 pi fourths, that means I'm in quadrant 4, so this has to be negative 1 over root 2. Or you could also write it, if you're rationalizing, as negative root 2 over 2. All right, cosine of pi 6 is 30 degrees, so cosine of 30 is going to equal root 3 over 2. Boy, that was easy, wasn't it? Okay, so let's take a look today at what's called implicit differentiation. All right, so we're going to start off with just a couple of problems that we're familiar with. We're going to find dy dx, and again, when you see dy dx basically means find y prime. Okay, or it means find f prime of x. All right, they all mean the same thing. So when I see y equals 5x squared, if I take the derivative of that, if I take dy dx, I end up, the derivative of y is y prime. Okay, so that's going to be important in a few minutes here. The derivative of the right side is just 10x. All right, so same thing, find dy dx, that means find the derivative. Well, the derivative of y is y prime, and the derivative of 10x is just 10. Okay, so the last one here, dy dx, if y equals x, the derivative of y is y prime, and the derivative of x is simply 1. Okay, let me see, what else we got going on here? Hang on one second. Alright, sorry about that. I was trying to decipher my notes here and something wasn't looking right, so I finally figured out what I was doing. So, alright, so I'm going to split this so we don't get confused here, but I'm going to toss in a couple more problems. So, what if we wanted to do dy dx, and we were going to take the derivative of 2y equals x squared. Alright? But the whole idea is, you know, I could divide by 2 and I could do it that way, and I could take the derivative just like we normally would do, but if I want to take the derivative, I know that the derivative of y is y prime, so the derivative of 2y is going to be 2y prime. Okay, so when it says take dy dx, and technically I probably should have this in parentheses here, dy dx of this, the derivative of y again is y prime. Well, the derivative of 2y would just be 2y prime, just like the derivative of 2x would be 2. And then the derivative of the right side here would be 2x. Okay? Now, if I wanted to solve this for y prime now, I would simply divide both sides by 2, and I would get y prime equals x. So the derivative of 2y equals x squared is just x. Alright? And again, we could do it the other way. If I took this same equation, you can see if I divide both sides by 2, I would actually have y equals x squared over 2. And if I took the derivative of that, if I took y prime there, y prime would equal, the exponent would drop down in the front. When it drops down in the front, I would have 2x over 2, and that just equals x. So implicit differentiation means that we're going to find the derivative, but what we're not going to do is we are not going to solve for y first. Okay, so we're gonna do what's called implicit differentiation. All right, so let's take a look at the problems here. Okay, and we're going to use all our different rules and that kind of thing here, but take a look at this first one. All right, let's go with some blue. I like blue. All right, so if I look at this, if I want to take dy dx of this, okay, the derivative of 2x is 2. All right, so that one's pretty straightforward. Now, if I look at the next one, I've got to use a couple of different rules here. And actually, I've got a plus sign in here, so we can toss that in here. So the next one here, this one gets a little bit tricky because This one uses the power rule. So if I were to take the derivative of 3y squared, I would bring the 2 down in front, I would multiply 2 times 3, and that would be 6y. Now, then I take the derivative of y, which is y prime. So the derivative of 3y squared is actually 6y, y prime, and then I take the derivative of the right side, and that's just 8x. Okay, so whenever you take the derivative of y, you'll always end up with a y prime, but if you have exponents and other rules that are happening in there, you may end up with, something like this, 6y, y prime. Okay, and now we're going to go ahead and solve for y prime. All right, solve for y prime. So I want to subtract 2 on both sides. I'll do that first, minus 2. I get 6y, y prime, equals 8x minus 2. And then I can divide out both sides. I can divide the 6y out on both sides, and I get y prime equals 8x minus 2 all over 6y. All right? So that's the derivative of 2x plus 3y squared equals 4x squared. All right? A lot easier than trying to take the derivative by solving for y first. All right? Look at the next one. All right? So the first part's easy. The derivative of 2x, or x squared, we know is 2x. All right? But here's where, again, it gets a little bit tricky, because when I take the derivative of 9y squared, I've got to use my power rule first. So the derivative of 9y squared is 18y, and then I have to take the derivative of y, which is y prime. So the derivative of 9y squared is 18y, y prime, minus the derivative of 4x, which is minus 4, and then the derivative of 3y. Now again, there's no product rule going on here, so the derivative of 3y is just 3y prime, and the derivative of the right side is 0, which is 0. Okay? So if you're using power rules or other rules, you're going to have to keep the y value in there, but if it's just 3y, then the derivative of y is y prime. Okay? So now again, we want to solve for y prime. Well, that means that I need to bring a couple of terms over to the other side, so we're going to go ahead and subtract 2x on both sides. At the same time, we'll go ahead and add 4 to both sides, because we're going to have to bring that over. And so I have 18y, y prime, plus 3y prime equals negative 2x plus 4. And then I'm going to have to factor out a y prime on the left side. Okay, I can't do anything until I factor that out, so that leaves me 18y plus 3 left over equals negative 2x plus 4. And then we're going to have to divide out the 18y plus 3 on both sides. So y prime turns out to be equal to negative 2x plus 4. This is all algebraic manipulation here. And then I'm going to divide both sides by 18y plus 3. And that's y prime. All right, next one. We got some trig functions here. So the left side, the derivative of sine of x, we know is cosine of x. So I'll start off with the derivative of the left side, that's cosine x. On the right side, this is going to get a little bit messy, because on the right side we have some chain rule going on here. We've got x squared times cosine of y, product rule going on here. So I need to pay close attention to this. I'm going to take the derivative of the first, that's 2x, times the second, which is cosine of y. I'm going to add to that the first, which is x squared, times the derivative of the second. Now, this is where this gets a little bit tricky, because the derivative of cosine is negative sine. So I would take the derivative of the cosine function, which is negative sine y, and then, based on my chain rule, I need to take the derivative of the inside material. I need to take the derivative of y, which is y prime. All right? Now, you'll notice y prime is pretty much kind of off by itself. It's just being multiplied, so I should be able to get y prime by itself here. So I'm going to go ahead and subtract. Yeah, we'll start by subtracting 2x cosine y on both sides. So I'm going to subtract 2x cosine y. These are not like terms, so I can't add them together. So now we have cosine of x minus 2x cosine of y equals x squared times negative sine of y times y prime. And in order to get y prime by itself, I just need to divide both sides by x squared negative sine y. So we're going to end up with cosine of x minus 2x cosine of y. We're going to divide all of that by x squared times negative sine y, and that's going to equal y prime. All right, don't need to simplify anymore. Okay, let's see what we got going on the next page here. Okay, looks like we need to scroll over a little bit here. It says, find the equation of the tangent line. Ooh, goody, a tangent line. What does a tangent line mean? A tangent line means a point and a slope. So number one, I need a point and I need a slope. All right. And then number two, it says find the equation of the normal line. Okay, well, we'll talk about normal line, but basically a normal line means it's perpendicular. All right, perpendicular. So we'll worry about that guy after we have our tangent line. And it says to the graph of x squared minus y squared equals 16. And they were so nice they even gave us the point 5, 3. So my point is 5, 3. All right. So I need a tangent line for that, which means I do need a slope. So my slope, I'm going to take x squared minus y squared equal to 16. And I'm going to take the derivative of this. Now, you know, if we were doing this mathematically correct, we would say dy dx. Oops, let me do this. I'll make it easier. I would say take the derivative, take dy dx of that function right there. All right. Actually, it's not a function because it's a circle. X squared minus y squared. No, that's x squared plus y squared. Nope. Okay. So let's see. What do we got going here? Derivative of 2x is going to be 2x. The derivative of negative y squared is going to be negative 2y, y prime. And the derivative of the right side is 0. So there's my derivative. Okay? Now, in order for me to find the slope, I've got a couple of choices here. I have my point, and so usually after we find the derivative and we find, after we take the derivative, then we plug in our x value from our slope. Well, you'll notice my equation right now has x's and y's in it, so that's why I need both parts of the point now. I need the x and the y to plug into here. And we could do one of two things. We could solve this for y prime just like we did, which might be easier, so maybe I'll go ahead and do that first. So we'll subtract 2x here, subtract 2x here. That leaves us with negative 2y, y prime, equals negative 2x. If I divide out the negative 2y on both sides, I get y prime equals negative 2x over negative 2y. And so y prime turns out to be equal to x over y. Now, I could have plugged in the 5, 3 way back here at the front end, or I can plug it in down here at the back end. So y prime, okay, so we're gonna bring our point over here now. So let's do this. I don't know how much room I'm going to need for the other one. So let's do, I think I got enough room on the right. Let's do y prime of 5, 3. So y prime of 5, 3 means plug in 5 for x, 3 for y. Oh, look, we're done. 5/3. There's my slope. Okay? So y prime is equal to 5/3. Okay? And again, remember, this is the derivative at 5, 3 on the graph of this equation up here. All right? So my tangent line now, we're still working on tangent line. All right? So the tangent line would be y minus y1, so my y1 is 3, equals my slope, 5/3, times x minus x1, which is 5, And so there's my tangent line. All right? The normal line is going to go through the same point. So the normal line needs a slope and a point. So my point, again, is 5, 3. My slope, however, because it's perpendicular, my slope is going to be negative 3/5. And then I just plug in again. Y minus 3 equals negative 3/5 times x minus 5. And we are done with that lesson. All right? Have fun with assignment number 4. Boom. There you go.